So Michael, are you good to go? Yep, awesome. Hi everyone, welcome and thanks for coming to my talk on AI war stories, where we're going to talk about the real world lessons from building enterprise AI solutions. I'm Adam Stephenson, I'm the AI lead at Agile Insights, and I'm lucky that I get to spend all day, every day building AI applications. Over the last couple of years, I've built and deployed lots of applications, primarily into education institutions like universities, a lot of public sector and government organisations, banks, insurers, and healthcare organisations. And really that's what I want to do today, is share those learnings that I've come across from actually getting stuff into production. When I talk to customers and when people come to me, they've often run proof of concepts, they've tried out the technology, they've used Copilot to stand something up, and I hear it over and over again. They get 80% of the way through, but getting out of UAT and getting into production, particularly in big enterprises and regulated industries, is really difficult. And really that's what I want to talk through today is, what can you be doing to get all the way to production and get value being delivered by AI in your organisations. We had a successful POC. We got stuck and we couldn't get it to prod. That's really what we're trying to address today. And when I came to building AI apps, I kind of looked at the components, and I'm a software developer, decades of actually building web applications. And you look at the key components and you go, what do I need to go and build an AI application? And I go and I can grab an accelerator. I've got some React. I've got some kind of an API in Node or .NET. I've got an AI search, which is really Lucene under the covers. It's an AI-enabled database. I'm working in Azure, so I've got some blob storage. And I've got my LLM in the background, but at the end of the day, it's just an API. I've got this. There's nothing here that should be different to what I've been doing for ages. After decades of consulting, every project, I want that 20% of, I don't want to be doing the same. The reason I'm a consultant is I don't want to be doing the same thing over and over again. I love adding a bit more, something new to learn on every project. So pushing it a little bit further, shouldn't be a challenge, but it is. And that's what I find with lots of organisations is getting the basics is really easy, getting to production is hard. Inherently, AI projects are riskier than web projects. When we come and we deploy a web application, we brainstorm, what the functionality we're going to need is, we prioritise features, we build a backlog, and off we go. When I was shipping pure web applications, I see there's a bunch of people I've worked with in the audience. Our standard was, day one, infrastructure as code, DevOps, deploy, dev, test, prod. You write code and you're shipping to production constantly throughout the project. And the reason you can do that is that you've got certainty around the technology. You know that the project is going to get to completion. You understand the components, and really it's about building new features as you go along. When you take that approach with an AI app, you come along, you brainstorm functionality, you prioritise features and build a backlog, and off you go. But when you get into UAT, you get pushback. Things don't quite work. You find out that the model output's inconsistent or wrong. You find out that the expectations mismatch from what the stakeholders wanted to what you can actually believe is hard to get going. And so once you hit that point, if it's a web application, it's relatively easy to go and change your approach, implement the features, take the feedback. When it's an AI application, the problems are bigger, and they tend to be, they're either architectural or even bigger than architectural, and they're not so easily solved. With web projects, there's a real delivery risk. You might blow scope, you might blow time, you might blow budget, but the technology risk is low. With AI, there's a lot more risk when it comes to the technology. There's a lot more risk when you get further into the project and you find out, the data that I'm being provided or the data that's available, it doesn't really support. It might support the beginning use cases that the user is interested in, but it doesn't actually support what they thought they were going to get out of the solution. So user expectation misalignment is really, is fundamentally, I think, one of the key pieces that stops AI projects from getting into production. Some of that has to do with model limitation. There's technical reasons why you can't progress. Often it's model limitations or accuracy. And that's what we're going to talk through is, both from a user expectation point of view and from a technical point of view, what are those blockers that are stopping apps from getting all the way to production? So I work for Agile Insights. This is our AI delivery, our Agile AI delivery framework. We absolutely still do. I worked for one of the most dedicated Agilists in the country. So Agile, is baked in. But being Agile doesn't mean you don't have a process. Being Agile doesn't mean that you don't get some requirements. So we build Agile delivery into our project. But what we find is there's some really important pieces in our delivery process that if we don't get right, they really unstick the project later in the process. And you'll see I've highlighted the key pieces in yellow that I believe are the critical pieces. A lot of them are right up front. It's, understanding, giving the customer an understanding of what's possible, prioritising the right use cases, running proof of values and proof of concepts. Getting the right detail when it's coming into the use cases and how the user are expecting to test the solution, and then getting the architecture decisions right. So they're kind of the things that I'm going to go through in more detail, is getting the right use cases, stakeholder education, which is absolutely critical, way more in AI projects than it ever was in web projects. That proof of value, proof of concept, and some of the architectural decisions and discussions that you need to be having with your teams. Look, I think more than anything else, picking the right use cases or picking the wrong use cases is how these AI projects go wrong. A lot of my time is actually working with customers to pivot them away from the wrong use cases or pivoting them around their use cases so they're working on the right things. 90% of what I've worked on with AI across my customers, both in Microsoft and now at Agile, they're building chatbots and co-pilots, they're doing knowledge search. And it's a great place to start on your AI journey. It makes a lot of sense for a bunch of reasons that I'll come into. I've got to say, I'm so excited that in the last 6 months, I've really seen that pivot. Instead of 90% being chat and knowledge related, I'm probably, I'm getting twice as many vision, voice, more interesting, intelligent automation scenarios coming up. And I think that's going to go through the roof with the new models that are being announced but aren't really mainstream yet. But going back to customers and making sure they understand, or in your own businesses, making sure that you're thinking about the breadth of AI solutions that are available is really critical. Making sure you're thinking about, what are the multimodal solutions that I could be doing. Intelligent automation. One of the best use cases I worked on at Microsoft was working for a bank, and they had a team of 25 people. Super simple use case. When you make an insurance claim, you upload receipts, you upload photos. They had 25 people in a room that were literally looking at an image, looking at a receipt, writing down what it was and filling in the field for the dollar value, writing the description of the car or what the photo was of, and then updating the overall claim to say, we've also received this. In a week's worth of proof of concept, that was fully automated, and that team was then focusing on speaking to the customers about the process instead of taking notes about things that AI could do. So really simple use case, really valuable output. Speech and language, I'm seeing a great uptick. As the models, as real-time voice becomes more accessible, which is just coming into preview as well. We're seeing more and more of these further use cases. And often the limiter on these edge cases is around the cost of running them. That's coming down as well. So, working with your customers to understand the full breadth that's available using PaaS services is really, really key. Having said that, most of the use cases that most customers are going to start with are still chat or knowledge search. I find that when I'm working with organisations, they really take one of two approaches to when they're getting into AI. One is to find one of those high-value use cases, the one like the upload descriptions, or the other one is, and especially in larger organisations, is to take a multi-use case platform approach. Instead of going, we've got one use case and that's going to save 25 people 30% of their time, saying, we know that we've got a people and culture and talent team. We know that we've got a policy team. We know that there's a whole lot of different teams across the organisation that if they're able to find information faster, if they were able to synthesise information, if they were able to take job descriptions and turn them into job ads, if we were able to take a whole lot of use cases across the organisation and enable users to create their own assistants, that we'd be able to get a really large amount of value from AI. And so we really find that customers that come to us are really fall into one of those two camps, and that's how we make sure they can see value from their AI investment. So I think when you're looking at use cases and when you're looking to what to build, moving beyond a proof of concept, finding one of those two paths is really important. This is on that finding one use case that's really useful, the AI doesn't have to be the big part of it. I've implemented this for one university, and we've had another university completely separately come and ask us to do this solution. The universities are trying to save costs at the moment. The scenario is they offer 3,000 subjects. They know that 5 faculties across the university all might offer an introduction to ethics course. Those courses have very similar student outcomes. They're almost running the same course across the whole university. But there's no one in the university who can go and say, hey, we could go and consolidate these 4 courses into one course, because no one has that domain knowledge. All of that data is in their student information system though. It took us a couple of days to go and suck out all the student course information, grab those silos, student intended learning outcomes, get the text, and actually just create a SQL Server table that had subject 1, subject 2, those silos, and then a percentage similarity. So really, really simple AI use case to say, how similar are these two subject requirements? Generate a single table, and then from there it just becomes a data engineering exercise where the data engineering teams come in and they pull in enrolment numbers, financial numbers, and then the Power BI team comes over the top. This knocks the socks off both of those organisations are like, this saves us an enormous amount of effort. We actually didn't have the skills to do this manually. We stood this up and we got the proof of concept working in under a week, and it's now going to enable them to save massive amounts of money. So these kind of little tiny AI use cases, this isn't chat related, but super valuable to organisations, just using those same technologies that we'd use for a chat kind of solution. So that's one approach. Question?
So they came with this requirement to you, or you said to them that we can do this for you? They came with a problem, right?
In both scenarios, so we're doing lots of use cases a lot. We're working with universities across Australia really intensely. And this subject rationalisation, so they came to us with, this is a requirement we have, could AI help us tell how similar our courses are? And we're like, actually, yes, very easily. And this actually gets branded, so this is a massive win for the AI team, very successful AI project. The AI team did like a week's worth of work. Really, this is a data engineering and Power BI project. It's pulling in all the surrounding data is where the value is. But it's that little bit of AI out the front that actually they couldn't do before that makes it super valuable. So being on the lookout for use cases where you can do this kind of a solution is really important. Question, William?
So, say that was a general common use case. Have you got any really obscure but highly ROI type use case that you've come across yet, where
There's
just blew their minds?
Well, so that one was one that was actually brought to us, and we did that really in a really short amount of time. They came to us and said, we think we could do this. We said, could you give us this data? And we just went back to them and went, hey, check this out. Is this what you're looking for? And they went, and just their eyes popped. Yeah. But it's a similar expectation to when we worked with Rebecca though, and then we gave them data in a spreadsheet and their eyes popped. Then it always happens, you might build the best website in the world and then you bring the designer in and the customer loses their mind because now it's pretty. The same thing when you bring the Power BI team in and they plugged in the rest of the organisation's data. I think that's one of the best use cases where small amount of effort for enormous impact. And these are in every organisation if you're thinking about what's available to build. When it comes to chat, and this is when I was talking about thinking about chat as a platform, one of the challenges I see in lots of customers is they'll go and they'll build a bunch of Copilots. And Copilot Studio is amazing. It gives you that ability to run a POC, grab some documents, crawl a website, grab data, create an AI system really easily that proves the value that a business could get over the top of using a little bit of AI. The problem with it is you end up with a whole lot of point solutions that are unintegrated, that don't have centralised governance. And it means you've got to use a developer for every single new use case. So a suggestion that I've really got that really makes sense in a lot of organisations is to say, let's go and build something that can enable users, not developers, to go and stand up their own use cases. So this is our AI1 solution. So you could build something very similar. So the idea is to enable a user to come in and go, new AI assistant, fill in a bit of detail, give the greeting, give the system message. Let them go and specify some of the, so any user can come and do this. We've got this running through government organisations. We've got universities where every lecturer, or everyone who's responsible for a subject, actually makes their course materials available via one of these assistants. So they're going in, new assistant, putting in a greeting, putting in the system message, attaching it to their course data and enabling their students to query their course data via a chat solution, which makes their learning so much easier. So, this can be so easy, you don't need developers to build this kind of a solution. You can actually have anyone who in Excel would have learned how to use a function. This is no harder than that. For people who are more technically minded, they might get into learning about what the different AI, what things like temperature do, and then, providing them enablement on that is really important as well. But it provides users the ability to build their own chat solutions that enable them to talk over enterprise data. So,
do you need Microsoft Copilot licenses for that?
No, so this is lots of our customers are using these kind of solutions because there's no Copilot involved in this. You could have, and this is in the universities and governments, 20,000 users of the system, but there's no Copilot involved, so they don't have to buy Copilot licenses.
So it's basically custom GPTs. Right?
Custom GPTs, but built in your own solution. Cool. So really good idea for if you're looking to build, don't build one at a time, aim for building platform. And this is a really simple design. So when you're actually back to very similar to what we were talking to previously, and this is one of the things that happens when people are coming and building AI solutions. You go and do a proof of concept, you go and download some accelerator code from the internet. There's a front-end app, there's an API app, you've got some AI search, some storage and OpenAI in the background. You can get going back with that really quickly. What you need to be thinking though is, what's the next step, particularly productionising in the enterprise? You need to be, so you want to get started as simple as you can, but you need to be thinking about what's the next steps going to look like. And these are usually things like most organisations are going to end up using, who's in Azure, by the way, just to get a fair bit of Azure going on, awesome. You're going to end up using APIM. Most large organisations are putting APIM between the APIs and the language model as an AI gateway. You're going to have to start thinking about doing things like private endpoints. You also want to, and this is as use cases go along, you want to be thinking about building your APIs that you're exposing to your front end in such a way that you can have multiple front ends connecting. The example is most of my customers at some point are coming back going, now we want to surface that chat using Teams. Now we want to be able to go and build a separate web component that's going to sit on our public website or sit in SharePoint or sit in our CMS system that's going to leverage that same API that we're using for our platform UI to be able to go and sit in other places. Another really common requirement I'm getting is we want different levels of control. We've got places like the legal department, or in health, we've got our clinical information. And we want the same experience, but we need to be able to lock down this more sensitive data in a separate deployment. So designing for that as well is really important. Other things to think about is how are you going to plug in directly to external data sources? How are you going to support multi-model and talking to external agents, which if we get time at the end, we'll do some talk about the multi-agent piece.
I'll put that in orchestration.
Yeah, I've left that till the very last slide. That's definitely, it's probably a whole another 5 talks. And the short version on the one-line one on that one is, it's too early. We've got 3 multi-agent projects underway at the moment, and it's moving so fast. You know, I wouldn't provide any guidance on that because the ground hasn't settled on it. And I think anything that's correct today isn't going to be where you land in 6 months.
Would you build it anyway though?
Well, I've got 3.
Yeah.
So I think then this comes back to this is another one of those key conversations with customers is, where are they happy to invest and reinvest? Or are they looking to, and this is lots of customers' points of view, is I want to invest now in the no regret scenarios, and then we're going to sit and wait till there's more stability, and then we'll invest in things like multi-agent later on. That's almost all of my customers are in that scenario, except for those 3. But yeah, when it really comes down to it, that the number one place where I see projects going wrong is in poor use case selection. I've got 2 columns of words. Can anyone tell me what's the difference between the words on the left and the words on the right? There's 2 different groups. I'll give you a clue. They're all verbs. I do this with customers. So whenever customers give me a use case, this is my verb test. And so what I do is, the verbs on the left are things that language models do really well. Language models are great at extracting, summarising, translating, rephrasing, identifying. These are all the things that your large language models are great at. The ones on the right are things that traditionally are things that are more of a machine learning task. Language models can have a go at them. And once again, it all comes back to so when customers bring me a use case, when I find that customers are struggling, often it's because they're using an LLM for a use case on the right and they just can't quite get there. Once again, back to maybe the use case either wasn't the right use case to choose, or they should have been clear about what was going to be possible right at the beginning. So I do this is the very first test I do when usually I work in consulting, so when sales brings me something, who works in consulting companies, just so I get an idea of. Only a couple. Okay, awesome. My position on this is machine learning is for data scientists and data engineers. I work in a team of where the AI practice. We're a team of developers. We've got people who have been, everyone's on the tools writing code. At Agile, we've also got a Power BI practice, and we've also got a data engineering practice. Data engineers are different people. When you actually see people who know about building models, they've got skills that it would take me a decade. The same way that they couldn't get my development skills quickly, it would take me a decade to get where they are with their real world, deep data science experience. So we divide those really very clearly, and there's a whole lot of tooling that's available for them that's making it easier and easier for data scientists. So Fabric and Databricks have both announced in the last couple of weeks the ability to actually build agents directly in their platforms. So what we're going to see is AI developers who are the code writers building platforms that are then connecting into agents that are being built by data scientists and data engineers. So, I really think that, I write code, I don't build models. There's a little asterisk there going, the tooling around this is getting better and better, and with local models next year I might have a different story.
Come back in 6 months.
Yeah, and this is often this thing is nothing's locked in stone. I think it will come back in 6 months, but I think do the job you do really well. So just as far as qualifying in and out use cases, I think that's really important to keep in mind. I always ask this question, for the data available and the models that are available, what questions can we ask or what tasks can we perform that are going to generate value? I think that's the question when we're building AI solutions. And there's a couple of asterisks in there, and really the data that's available may not be the data that's available right now, because if you want great solutions, you're going to go out and you're going to whack that data around a bit. You can look at the data that's available. I've got many stories around where we've taken failing projects and we haven't changed the solution. What we've changed is we've done a whole lot of data engineering to provide the data in a format that's more consumable to answer the questions that the user wants to ask. And the same thing with the models available, particularly in, there's the rate at models are being released is really fast. Depending on your requirements, lots of my customers can only use models that are deployed in Australia. That means, all of the logic-capable models aren't available at the moment. Even GPT-4o, if you want to use it and you've got a data residency requirement, you need to buy a PTU, which is, $14,000 Australian to be able to use it. So what models are available is a really critical thing to understand to determine what use cases you can address. So once we move on from that, the other one that derails so many projects is just that the expectation around accuracy. I love going in and asking at the beginning of a project, so what percentage accuracy is required for your use case? What does everyone say? 100%. If it's not right, it's not right. Is always the reply, and it's a really critical conversation once again to have right at the beginning with user expectations. I pivot that around usually by saying, look, in your organisation, if I went to your team and I said, there's 5 jobs you're doing, could I give you 5 interns? And those interns are going to go and their job is to accelerate your job. So they're going to go and they're going to search for information and they're going to bring you back the information. Sometimes they won't get all of it. Sometimes they'll bring you back information that's not quite the right information. But if I could give you 5 interns, is that going to make your life easier? The answer is almost always yes. Not for every use case, but usually. And often this is when it's not an in or out for use cases. It's the way you need to think about use cases. And this is, once again, stakeholder education and refining the use case to be something that's deliverable is really key. So when it comes to accuracy around the solutions, once again, data. The structuring your data. I've got a customer that's ingesting 60 gig of data. They run they're government customer, they run a couple of hundred infrastructure projects. Every project has thousands of documents submitted as it goes on. They want to be able to ask questions over this data like, tell me between last quarter and this quarter, where were there increased risks of budget blowout? So when you think about that kind of question, we need to be able to identify what documents were available last quarter, what's from this quarter, where are we talking about, budget risk increases, and how the structure that you provide that data in is how you can work with the model to actually segment the data to actually return valuable results. Because if you leave it up to the model, your results aren't going to be great. You've actually got to do some work to make those kind of things, give you a really valuable answer. So, making sure you've got the right data and it's in the format that you can use it. They're also, they're doing a whole bunch of work where they're taking unstructured data. You could run a whole session just on data prep and on the, whether it's pre-processing or, working with that data, moving it into Excel as opposed to, just having unstructured data. Lots of things you can do there. So that's even outside of the solution. In the solution, there's definitely technical things you can do, hybrid search, semantic re-ranking, query re-ranking. There are things that you can do in AI search, and I'll talk about that separately, that are really valuable for increasing accuracy. Same with revalidating the answer. There's technical things you can do, but primarily, when it comes to accuracy, it's about expectations, getting the data right. And then I'll talk about search rather than chat. there are lots of solutions that shouldn't be a chat solution. And I'll talk about that in a second. I've had lots of customers come and they think they want a chatbot. They're used to a ChatGPT experience. They want to have all of their data, they want to have all their policy information. So especially in government with policy, in medical scenarios, they want to be in insurance scenarios. They want to be able to ask a question and they want the LLM to bring them back. They're going to provide a whole lot of data, a whole lot of policy documents, and it's going to bring back an answer. I had a customer who'd spent months bashing on their system prompt, putting their temperature down to 0 to supply the model with data and have it return it exactly how it was sent to it. And I'm like, that doesn't make any sense. And their approach was, if it's not 100% right, it's not right. When you're talking about medical information or really critical policy information, those things can be really important. So that's a use case that we want to come up with a different solution for. We see, often I have customers come to me and we go, we want to go and build this solution. We're going to go and put it on our public website and we're going to allow all of our prospective students to go and ask questions. I'm like, do you really want to actually go and, as your first AI solution, go and make something that's public facing? I get this all the time. I've got an organisation that wants to go and build something that's going to go in their foyer, once again, and talk over data. But they don't have any AI expertise yet. They don't understand whether the AI is going to answer the questions correctly. So really, when you're looking at use cases, pivoting from being public facing to saying, first of all, let's go and build an AI system that enables our internal teams. Let's go and work on the data and work on the solution so that we can have the internal people who would be answering the questions working with that AI first, so that then when we do make it public facing, we've got trust that it's actually going to work. So use cases that are public facing are really high risk. So we definitely want to pivot those. Same with sensitive data. If the data is sensitive, we're better off when we're starting off choosing something that's, less secure. Customers from the expectation game also want to be able to say, I've got all of this data, I want to be able to ask any question over it. The expectations game is absolutely key. What's really important with all of these use cases is, initially demonstrating the return on investment, saying, yes, AI can do amazing things, but then really quickly as you can, proving what's possible and what's not possible. So run a proof of value, get stakeholders excited, but then really quickly you want to be moving into validating what's possible. Validate that the model capabilities, validate that the data is ready to be able to answer the kind of questions, and validate expectations. This is something I didn't need to do when I was building web projects. I knew that if the customer changed their mind, I'd be able to accommodate what they were asking. It's really common now, if you don't understand that, for example, the customer has all of this data and they want to be able to compare periods for the data that they've got, that you won't be thinking about that at the beginning, and you'll get to getting into UAT and they'll have an expectation that's unable to be met and the project won't go forward. So getting an understanding of what the critical success factors are earlier in the project is really super important. And so we'll often run multiple proof of concepts before we deploy the production environment. We'll understand what do you really want, and the customer's going to change their mind, but you want them as early as possible to be thinking about what are the questions they want to ask to get what value out of the solution. So always running proof of concepts. This is always, we've been saying fail fast for decades, but, really celebrating early failure. Discovering early that a use case won't meet the user's needs without major effort isn't a failure. It's a really valuable insight. And it comes back to setting expectations with the customer of, we're doing this to make sure that we can deliver a solution that you're going to find valuable. So that education piece is absolutely critical. And I run, there's a couple of decks I run with every customer I customise it for that customer, and then I deliver it to the key project stakeholders and the technical teams. And then whenever anyone comes on the project, we always request that they come and they essentially get onboarded to get that basic knowledge. Before anyone can work with AI, we think it's really important they understand what large language models are good at and what they're not great at. Whether they're stakeholders, the security team, the architecture team, and particularly the testers. These are all people, groups of people we have problems with later in the project if they're not brought into the AI vision at the beginning of the project. Because at the end of the day, AI might look like magic, but it's not. And this is really these are important messages to land. What is an LLM and how does it work? What does it do well? What doesn't it do well? And so I'm going to quickly run through these slides, but this is my stakeholder engagement piece I do at the beginning of every engagement to make sure everyone's on the same page. And how RAG actually works. I stole the idea from Scott Hanson, and I'm going to do it pretty quick. Who's already doing LLM solutions in their organisation? Oh, okay, only a few. Awesome. Now, this is non-technical, but it might be useful, I'm sure it will be useful for you when you go back to your organisation to help them get them on board with how an LLM actually works. With organisations, who remembers Family Feud, the game Family Feud? Awesome. The way language models work is it's like Family Feud. It's like you've surveyed the audience and said, I'm going to give you, there's a question, I'm going to survey the audience and find the most likely answer. It's a lovely day, I want to go to the beach. Next most likely answer? Pub. Who said pub? That's awesome. I should have thought of pub. Beach and park are probably by far the two most likely answers. Now I'm thinking about pub. And then that's how an LLM works is, it's probabilistic. It's saying for this particular question, for this particular string, here are the most likely next tokens. And for that question, the most likely answer is going to be pub or beach. I can come along and give it additional context. I live on the Gold Coast. Now when I come along and I say, it's a lovely day, I want to go to the most likely answer is strongly going to be beach. If I come and say I live in New York City, it's a lovely day, I want to go to the most likely answer is park. What I can do is provide more context, more detailed context. There's two large retail, and this is what I use to explain how the LLM is working. There's two large retail stores in a shopping centre, there's Target and Coles, there's an information desk, there's a coffee shop inside next to Target. I introduce the idea of a system message. I can also tell the AI what it's supposed to do, how is it supposed to behave. Your helpful information kiosk assistant for a small shopping centre only reply for the answers for which you supplied information. If you can't find a valid answer, suggest the user contacts the manned information desk next to Coles. So now I've given it more context and I've given it instructions. I then come along and type the same question. This is a more real life scenario and I get a more real life answer. I get an answer like, it's a lovely day, you might enjoy visiting in the outdoor kids' playground. It has benches for adults to sit on. If you're looking for some coffee, there's a coffee shop inside next to Target. If you need any more information, feel free to ask or visit the manned information desk next to Coles. This is a really simple explanation, but it's really critical as we go through use case development and through testing, getting the stakeholders and the testers around what's actually happening with an LLM helps them understand why things work and why things don't work. I then take them through this kind of a diagram. You've got your query, you type your query in from the user that goes into your web app. And I show this to stakeholders. I really focus on this with the technical teams, particularly the testing teams. The user types in a query, that query goes off to the AI engine and it comes back with a response. That response that then gets given back to the user. Now, when in our enterprise scenarios, what happens is we want to suck in big bits of data. So we enable in our solutions the user to upload their information. What I'd suggest is most enterprise customers, they want to export data, whack it in blob storage, and then ingest it into AI search. So AI search is essentially your AI database. And you can so the way we do that is data gets dropped into blob storage. It can emit an event of what that file was. That file gets put in there's an event grid message that gets put in a service bus queue, and you can pick up that file then go and talk to an embedding model to embed it, and then go and put it into AI search, which is the AI search data, which is essentially the AI database. So you have this whole document ingestion process. And it's really important that everyone understands what's happening under the covers with RAG, because this is the most commonly debugged part. Why, when I upgrade my system prompt, am I not getting the right files returned? That's by far where I spend most of my debugging time for solutions that we've developed. And the reason for it is this: when you type in a query, when you're doing, who's doing RAG at the moment? Who's already implementing RAG? A few. So the RAG pattern, so I should actually take back at a high level. The RAG pattern is by far the easiest way to add value in organisations doing AI. It's the pattern we use for to enable users to talk over the top of, enterprise data or a set of data. I want to go and query policy documents, and I want to upload all of my job descriptions. I want to be able to turn my job descriptions into job ads. I want to take all of everything that the government's announced in the last 3 months and turn that into a briefing note to give to a minister. So this is by far the most common AI pattern that we do across all of our customers. And we're taking that enterprise data, and we want to go and make it the LLM, use the language model to be able to work over the top of that enterprise data. But to be able to have it generate or do interesting things with the language model, we need to find the right chunks of that data to be able to hand off to the language model. And the way that works is that when the user types a query in, the query gets passed off to AI search, which is loosely under the covers, but you can really think of it as being an AI-enabled database. So it hands that query off to AI search. AI search then finds the right chunks of the documents, the relevant chunks, and hands them back to your web application. At that point, it then takes those chunks of documents and it hands those chunks of the documents off to the large language model, along with the prompt that the user typed in and the chat history. So now you're sending the user's prompt, the chat history, and those document chunks returned from AI search and the system prompt off to the language model, which takes all of that, creates a nice response, and then gives it back to the application, which gives it to the user. That is by far more than 90% of the AI apps that are being written today. Where it goes wrong and where it's really misunderstood is you can write that system prompt that we wrote that defines what the AI is doing. You're a helpful AI assistant. Your job is to take job descriptions and turn them into job advertisements. Here are the sections that you're needing to include in the job ad. The system prompt is where you give the AI instructions. A lot of users put information in the system prompt that they're expecting to help retrieve the right documents when they're doing the document search section. That doesn't get passed. The system prompt isn't used for retrieving the documents. And so that's why I use this diagram with customers all the time, because running through it again, so this is, if you don't take anything else away, this is get your use cases right. And this diagram of going, RAG is 2 parts. RAG is retrieving documents from a data store and then sending those documents along with the system prompt, the user's prompt, and the system message off to the LLM for processing. But usually, depending on what you're using, if you're using AI search, then that system message isn't sent to AI search to retrieve the documents. So getting that document retrieval part right is where I do most of my debugging. It's actually where most of the challenge is. It's where most of the technical investment is. And I say this to teams that are asking us to come in and enable them all the time. The LLMs are simple. Semantic kernel's worth, investing in your framework, semantic kernel, LangChain, your multi-agent frameworks, there's investment there, but your LLMs are actually really simple. The piece that's real, if you're going to be in the Azure space, absolutely really invest in the nuts and bolts of AI search, custom indexing, and how that piece works, because that's the difference between building a really great solution or really being hamstrung by the technology.
So if you can't update the system prompt to give direction on which document to look for information, where do you have to put that information in the documents?
So this is absolutely key to, you don't need to put them in the documents, but what you'll do is, and this is when you're doing your indexing, so this is back to and this is why I really jumped up and down on the data piece at the beginning. When you're doing this data ingestion, what you're often doing is because you're also remembering you're breaking up the documents and chunking them as you're bringing them in. So we do a lot of work in custom indexing where we'll often pre-process our documents. We'll actually go across the document and say, for the customer with the 60 gig of data that they're bringing in, 60,000 documents, they're submitted by they're submitted by contractors. They're poorly named, they're poorly structured. We're actually pre-processing those documents to categorise them as they come in. So we're actually, as they're coming in, determining what date was the document. We're using the LLM to determine what date was the document written, what type of document is it, and we're doing a whole lot of that extraction. We're actually often pre-processing documents to go, what are the key risks identified to schedule in this document? And in AI search, it's a table. You can have custom fields of metadata. So we're extracting that metadata and putting it in AI search to make it easier to get the right document chunks out of AI search.
Tagging it.
So essentially it's tagging it. And we actually build tagging and an artificial folder structure into the document ingestion process so that we can actually filter it. It's probably the most complex part of the whole solution is the bottom box of getting the data structure right and ingested the right way rather than working with the LLM. Yeah, that's definitely where we spend most of our time. So getting the understanding to the team of how this works is really important. As I said, there's a whole range of AI use cases. So AI can do amazing things. Understanding what AI doesn't do well is really important. I run through these slides all the time because this is expectation setting, once again, is key. AI might look like magic, but it's not. When you're building an AI system, I can say this now because I don't work at Microsoft anymore. Microsoft's great at building things, but they're terrible at naming stuff. The only thing they ever named well was Copilot, and they stole that from GitHub. But the Copilot is the best name because that's what you should be aiming when you're building an AI solution, to be building. You're not building, and this is, once again, it's changing with agents, and what everyone's going to tell you is agents can go and do stuff. I don't want my AI yet to be doing stuff. I want to be building a Copilot that's enabling me, that's assisting me, that's helping me out. If Tesla's proved one thing, there's lots of things that Tesla has proved, but this is a really important message to get out to users. Replacing people with AI is harder than you would think. That last 2%, the last 3% is really hard. This is really reassuring. I've had a team that was super keen on our solution. They completely backflipped because they went, this is way too powerful, we're going to lose jobs. We don't want to lose jobs, we've gone cold on AI. But talking to them about the fact that it's about enabling people to do their job better, to do that part of their job that AI can't do. Let's make everyone's life easier is really important to land as a message. At the end of the day, AI copilots are AI tools that can increase productivity. Think of them like a calculator. And like a calculator, you can just use the big buttons and the numbers. But if you're interested in learning how to use all the advanced functions, you're going to get a better outcome. This one's really key, and this is that message I land really early with customers, is the AI solution won't always supply the right answer. There's ways to get around this though. What you need to be doing is using tools like citations. When you do supply an answer, provide the source, make it easy to get back and see the source materials, link back to the original documentation so that they can see that. And think beyond chat. Chat's great, chat's valuable, everyone's doing chat, but there's a whole lot more that you can do. But the goal of generative AI is to enable user acceleration. It's to actually go and say, it's not going to do the job for you, but can I make your job, if I could make your job 30% faster, would that be valuable? How am I going for time? Pretty quick. There's a bunch of technical challenges. Knowing where to start is really tough. There's so many AI accelerators out there. Getting the right one can be really tough. Copilot is great. Azure Chat is great. That's something that we really struggled with. We tried a few of them and then ended up building our own. I'm very happy to chat about pros and cons and what's around, but that's getting the right place to start at the moment is particularly tough, particularly if you're looking to do multi-agent, MCP, A2A, all of those kind of things. There's no one really strong source of truth. We talked about accuracy. The word-for-word responses thing. This is when it comes to solutions that need high level of accuracy. There's a lot of solutions that are actually search solutions. They're not chat solutions, where users say, I want the original documentation. What we've done, and something to think about, is instead of a chat solution, provide a search solution. Go and query, so that's why this document's here. When you get those original document chunks, hold on to those document chunks. And there's a lot of generative AI solutions that just providing back those chunks of information back to the user are actually what they want, not something that's been processed by an LLM. How we do that often is when we're creating our assistants, we give the UI the choice, is it a chat solution or a search solution? If it's a search solution, we give this tabbed solution where we give a brief AI answer that's been through the LLM, but the key part is actually coming through and saying, here is the source that's actually, this is the word-for-word chunk that was indexed into AI search and giving that directly back to the user. Once again, expectations management. That's plain text because of how it gets ingested into AI search. Are you, Mr. User, going to be okay with that? Providing a preview really helps with that, previewing back to the source doc, back to linking, so they can hit preview, link back to the source document. But once again, there's limitations on that, is that you're getting the whole source document, you're not getting just the section that they might have been searching for. So all of these things successfully getting deployed is really often about establishing those user expectations early. There are a bunch of limitations around AI search, things that aren't easy to do. RBAC is a real challenge, sorting the data into files, folders, tags. All of these things are doable. Happy to chat to anyone around different implementations and how they might be wanting some help around that. But yeah, AI search is where a key piece of the puzzle is. Filtering data. Really, So with AI search, when you're coming in, a key piece of it is around role-based access control. This is one of the real challenges that organisations have when they're going and building an AI platform solution. I've got the HR team, I've got the people and culture team, I've got the legal team. We want to put all of that data into the same AI database, into AI search. We want to have multiple assistants that can query over that same data. How do we lock that data down so that only some people can see, only the people in the legal team can see the data that's ingested? Very similarly is when we upload data, we want to be able to segregate it out. We want to be able to say this particular data is going into this folder or this particular data is going into this. We might want to tag things as different document types. All of these things aren't built into AI search, but you can build them. But it means going in and working through that metadata, using the metadata to artificially create these constructs. So it's all possible, but it just takes a bit of work. So at a high level, when I think about what's really important, proof of concepts are mandatory. They really you really want the customers, you want your organisations looking at what you're building, thinking about what their outcomes are, what are the questions they want to ask to get the value that's going to give them that acceleration. Making sure the data is viable and make sure that the stakeholders understand, finding out the limitations early and being clear about those early is really important. it's an amazing time. We're going to look back in 12 months at the solutions we're delivering today and think they look like, baby solutions. The acceleration, the models that are coming, the tooling that's coming, the frameworks that are coming, we're going to, I can't wait to see where we're at this time next year. It's hard, it's emerging. I've deliberately stayed away from it, but I'm around, and if anyone wants to talk about it, I could spend, the rest of the week talking about this, so please come and grab me. But when it comes to, if you're going to build an application, you want to get it all the way to production. What I'd really say is that if you're an application developer today, you've actually got the skills to go and build AI applications. But the key to it is just understanding those extra couple of components, understanding the nuances around AI search, and really working with your organisation to understand what the risks are and removing those risks from your project as early as possible. Proof of concepts on the target data is absolutely essential, and getting the stakeholders up to speed early. Start small, start safe, and then scale out. I hope this has been valuable. I'll take some questions I'll probably wait till I get outside. There's another speaker coming in, but I hope that's been valuable. I'm around. Please come and say hi, and thank you very much.